Riprenderei adesso dando la parola ad Alina Secara, che non
Sì, è qui.
vedo c'è. Pregherei tutti i relatori di rinominarsi. Possono cliccare sui 3 puntini in alto sulla loro immagine e scegliere rename e rinominarsi, per favore.
Yes, Alina, could you rename yourself as well? Because here it just says rapporteur. There's no indication of your name. So luckily I know what you look like. If you click on the 3 dots, you should be able to rename yourself. There you are.
Thank you, Alina.
No problems.
So I'll leave the floor to Alina, who will be the moderator for this session that will be focusing on the work that the institutions are doing on speech-to-text recognition. Alina, please.
Thank you very much. Can you hear me okay?
Yes.
Okay. Thank you. Hello, everyone. I hope you had a nice and enjoyable, if short, lunch break. It is my pleasure to moderate the third session of this event. My name is Alina Secara. I am from the Center for Translation Studies at the University of Vienna in Austria, and I am one of the 5 co-organizing universities of this event, who supported the great effort that Annalisa and the DGT colleagues in Rome put to make this possible. So in this afternoon session, we are going to concentrate on speech technologies, and we're going to have 2 interventions from the institutions. The first one is from the Parliament, and the second one is from the Commission. The first one is titled Live Speech-to-Text and Machine Translation Tool for 24 Languages, and it's going to be delivered by 2 colleagues, Martina Giannarelli and Marcin Feder. So the floor is yours. You have approximately 25 minutes, and then we will take questions. Thank you.
Hello. And hello, Alina. Can you hear us? Long time no see and no hear. Good to see you. I will just briefly introduce our topic, because it's not me who's actually presenting, but Martina. We decided to do it in Italian, so she will do the honors on behalf of the unit. We are in the European Parliament implementing a project aimed at live transcription and machine translation of our plenary debates, mainly for accessibility purposes. So our primary audience is the deaf and the hard of hearing people. And as I said, I will be lurking in the shadows. Martina will present, and I will be very happy to help her answer any questions you might have after the presentation. So without any further ado, I would like to hand over to Martina for the actual presentation. Thank you.
Thank you very much, Marcin. Thank you, Alina, and all the organizers who invited us today. I would like to start sharing my screen, and when the presentation is set, I will switch to Italian for my presentation. So I will just set up the screen. Would it be okay to confirm that the presentation is displayed correctly for the participants?
All good.
Ok. Molte grazie, buon pomeriggio a tutti e grazie ancora per l'invito. Come il mio capo unità, il dottor Marcin Feder, ha anticipato, siamo molto lieti oggi di essere qui a nome di tutta l'unità Speech to Text e della Direzione Generale per la Traduzione del Parlamento Europeo. Oggi siamo lieti di presentarvi il nostro progetto su cui lavoriamo ormai da più di 2 anni. Si tratta di uno strumento, o in altre parole di un software, di trascrizione e traduzione automatica in tempo reale delle 24 lingue dell'Unione Europea. Un progetto che stiamo portando avanti grazie a uno speciale partenariato per l'innovazione, cioè una speciale forma di collaborazione tra il Parlamento Europeo e alcune aziende del settore privato. Prima di addentrarci nel progetto in sé, vorrei spendere 2 parole per dirvi chi siamo brevemente. Come ho anticipato, siamo parte della Direzione Generale per la Traduzione, abbreviato con l'acronimo DigiTrad molto spesso, e all'interno della Direzione Generale apparteniamo alla Direzione della Lingua dei Cittadini, una direzione piuttosto recente che ambisce a rendere i contenuti del Parlamento europeo accessibili in diversi formati per tutti i cittadini. Abbiamo infatti all'interno di questa direzione diverse unità, tra cui speech to text, ma anche un'unità di sottotitoli e voice over, una di audio e podcast e un'unità che si specializza nell'utilizzo del linguaggio chiaro. Siamo perciò un'unità piuttosto giovane, fondata più o meno 2 anni fa, poco più di 2 anni fa, e l'unità si compone di un team piuttosto piccolo, diviso tra Bruxelles, come nel caso del mio capo unità, il dottor Feder, e Lussemburgo, come nel mio caso. Quindi grazie all'uso della tecnologia e dei supporti per interagire da remoto, i 7 dipendenti di quest'unità ogni giorno lavorano insieme nella supervisione del progetto di cui vi parlerò. È un'unità anche piuttosto interessante in quanto proprio per via della speciale natura del nostro progetto si compone di profili piuttosto eterogenei. Abbiamo colleghi specializzati in linguistica computazionale, altri specializzati in informatica o nel settore audiovisivo, solo per nominarne alcuni. Vediamo adesso di cosa ci occupiamo su base quotidiana. Il nostro ruolo principale è la supervisione del progetto Live Speech to Text and Machine Translation Tool in 24 Languages, come ho anticipato nel titolo della nostra presentazione. Andrò presto a illustrarvi le fasi del progetto e il suo obiettivo, ma vorrei anche ampliare un attimo i ruoli principali della nostra unità, che comprendono anche il mantenersi aggiornati sugli sviluppi delle tecnologie del linguaggio applicati alla traduzione e al Parlamento al Parlamento europeo, e proprio qui esploriamo le opportunità di impiego di questa nuova tecnologia speech to text. Vogliamo capire come meglio applicarla nel contesto del nostro lavoro e per un positivo uso sia per i nostri membri a livello politico sia per i cittadini. Vediamo adesso di cosa si tratta il progetto LSTT, come noi di solito lo abbreviamo con questo acronimo inglese. Stiamo lavorando sullo sviluppo di un software, uno strumento di traduzione e trascrizione automatica in tempo reale in tutte le 24 lingue del Parlamento europeo. Questo software, che sarà accessibile online direttamente tramite il browser di qualsiasi computer o dispositivo dei cittadini, vuole rendere le sessioni plenarie del Parlamento europeo più accessibili per persone sorde o con deficit auditivo. La peculiarità infatti delle sessioni plenarie è il multilinguismo, in quanto tutti i membri del Parlamento europeo sono liberi di parlare all'interno della sala della sessione plenaria in una qualsiasi delle 24 lingue, senza preavviso. Questo è ampiamente diciamo reso accessibile per le persone udenti tramite il servizio di interpretazione simultanea, ma al momento non c'è un servizio in diretta di trascrizione automatica con tanto di traduzione automatica per le persone non udenti. Per questo motivo siamo molto orgogliosi di portare avanti questo progetto che vuole rendere più accessibile i dibattiti europei. Per quanto riguarda il funzionamento del software, come ho anticipato nella slide precedente, gli eurodeputati possono parlare all'interno dell'aula della sessione plenaria in una qualsiasi delle 24 lingue. Per questo motivo, proprio a causa dello speciale scenario multilingue della sessione plenaria, il nostro software si basa prima di tutto su una funzione automatica di identificazione della lingua. Il software è quindi allenato per poter riconoscere immediatamente, solo dopo qualche secondo, la lingua che viene parlata dall'oratore, e questa lingua viene automaticamente trascritta grazie al sistema di riconoscimento vocale automatico. Se immaginiamo quindi che un eurodeputato si rivolge ai colleghi in inglese, questa lingua verrà automaticamente identificata e automaticamente trascritta. Sarà quindi accessibile in diretta con una trascrizione che appare parola per parola sul browser per l'utente in questione che vuole seguire il dibattito. Dobbiamo però poi immaginare che dato il grande livello di multilingualismo in Europa, dall'altra parte dello schermo potremmo avere una persona non udente o udente, se vuole seguire comunque una trascrizione in diretta, che non capisce la lingua originale. Per questo motivo abbiamo aggiunto al software un sistema di traduzione automatica, anch'essa in diretta, che possa tradurre automaticamente la lingua originale verso la lingua scelta dall'utente finale. In questo modo potremmo garantire un'accessibilità in tutte le 24 lingue dell'Unione. Questo software comunque ha ovviamente altre funzioni che abbiamo dovuto sviluppare, non solo quelle linguistiche, anche se quelle linguistiche sono quelle preponderanti, essendo il software sviluppato all'interno del Digitrad. Abbiamo però dovuto anche interfacciarci con altre funzionalità da sviluppare. Abbiamo già parlato dell'identificazione della lingua e della trascrizione automatica, che è, se vogliamo, il primo passaggio che entra in funzione sul software. La traduzione automatica è quello successivo, quindi la scelta dell'utente della lingua di arrivo che preferisce. Abbiamo però anche altre funzionalità più tecniche, come l'apprendimento automatico e l'interazione uomo-macchina. L'apprendimento automatico è la funzionalità che permette ai modelli linguistici di ricevere dei dati che noi mandiamo regolarmente ai nostri collaboratori per poter abituare il software, quindi tutti gli algoritmi, a tradurre e trascrivere correttamente determinata terminologia, acronimi, nomi che diciamo vengono spesso utilizzati nell'ambito europeo, quindi quello che in inglese chiameremo EU jargon. L'interazione uomo-macchina invece comprende una funzionalità per la quale andremo in futuro a migliorare la trascrizione o la traduzione automatica per poter, grazie al feedback dei nostri esperti linguistici di Digitrad, per poterne migliorare la performance in futuro. Ultimo ma non meno importante, ci stiamo comunque focalizzando anche su migliorare le funzionalità dell'interfaccia utente, che è multidispositivo, quindi accessibile da tablet, smartphone e computer personali o portatili. Questa interfaccia comprende già determinate funzionalità che vogliono aumentare l'accessibilità per gli utenti, come per esempio il cambio del colore del background, quindi lo sfondo bianco o nero per una migliore leggibilità, il cambio di dimensione del font o dell'interlinea. Tutte queste caratteristiche vogliono rendere l'interfaccia più facilmente utilizzabile dai nostri utenti. Nella slide precedente ho menzionato l'addestramento del software, quindi l'apprendimento della macchina come una delle caratteristiche, delle funzionalità più importanti del nostro strumento, e ho detto che ci occupiamo regolarmente come unità di fornire dati ai nostri collaboratori in modo da poter migliorare i nostri modelli linguistici sulla base della terminologia delle sessioni plenarie. Vorrei quindi illustrarvi brevemente che tipo di dati forniamo regolarmente per tutte le lingue che stiamo sviluppando. Forniamo regolarmente live streaming e quindi in diretta accesso all'audio e al video delle sessioni plenarie, ma anche registrazioni dei dibattiti di tutti gli anni precedenti, i rispettivi testi di riferimento, quindi i verbali di tutti i dibattiti degli eurodeputati, gli ordini del giorno e le memorie di traduzione per poter migliorare l'output della traduzione automatica in tutte le sue combinazioni. Come diremmo in Italia, però, Roma non venne costruita in un giorno. Per poter raggiungere un obiettivo tanto ambizioso c'è bisogno di tempo e molto impegno. Il nostro progetto, infatti, ha una durata di circa 3 anni e si divide in 3 fasi. Siamo al momento alla fase numero 2, ma vorrei illustrarvi fin dall'inizio come viene sviluppato questo software. L'inizio ufficiale del partenariato per l'innovazione di cui siamo parte è stato in settembre 2020, quando dopo una lunga selezione tramite una gara d'appalto da 11 aziende del settore privato che hanno espresso interesse verso il progetto, ne sono state selezionate 3. Le 3 aziende che sono riuscite ad arrivare alla fase 1 si sono dovute impegnare nello sviluppo di un prototipo che potesse supportare le 10 lingue più regolarmente utilizzate durante le sessioni plenarie, quindi le lingue più grandi a livello di dati, tra virgolette, non per importanza ma per utilizzo di dati, per esempio dall'inglese al francese, lo spagnolo, l'italiano. Fra queste lingue, una volta sviluppate queste lingue su un iniziale prototipo, i 3 candidati sono stati analizzati tramite un processo di valutazione linguistica dagli esperti di Digitrad. Quindi noi come unità Speech to Text ci siamo occupati di organizzare un processo di selezione di un candidato su 3 sulla base della qualità linguistica dell'output prodotto dal loro prototipo, sia per quanto riguarda la trascrizione automatica in tutte le 10 lingue, sia per quanto riguarda la traduzione automatica, quindi la valutazione di tutte le combinazioni qui tra le 10 lingue indicate. Una volta selezionato un candidato che al momento continua a lavorare con noi, continuiamo verso la fase 2 e la fase 3. Nella fase 2, che è quella attuale, ci troviamo ormai alla sua conclusione, stiamo sviluppando nuove lingue, ancora una volta procedendo dalle lingue con più dati, quindi più spesso parlate nelle sessioni plenarie, verso quelle con meno dati. L'anno prossimo procederemo all'ultima fase, la fase 3, che ha una conclusione prevista per la fine del 2023 e durante questa fase raggiungeremo il completamento delle 24 lingue, sviluppando le ultime 5, quelle che sono più limitate in quanto a frequenza di utilizzo e dati. Durante tutto il procedimento l'unità Speech to Text si occupa di cooperare con i nostri collaboratori, l'azienda che è stata scelta, fornendo continuamente consigli e suggerimenti per migliorare i modelli linguistici, ma anche per migliorare l'interfaccia. Quindi, come anticipato prima, la nostra collaborazione è veramente quotidiana. E con essa anche la valutazione dei modelli linguistici continua. Quindi dopo una prima selezione e valutazione qualitativa dei primi 10 modelli, continuiamo comunque regolarmente a valutare i nuovi modelli delle lingue aggiunte e rivalutare i modelli precedenti per confermarne i miglioramenti. Il partenariato per l'innovazione di cui vi ho parlato finora è composto, come dicevo, dal Parlamento europeo. Nel nostro caso l'unità Speech to Text si occupa di supervisionare il progetto in collaborazione con un consorzio di 3 aziende, capitanato da CEDAT 85, un'azienda italiana esperta in trascrizione automatica. Sono loro, in cooperazione con RWS e Bertana IT, che si sono aggiudicati la fase 2 e la fase 3 del nostro progetto. RWS collabora con Citato 85, in particolare si occupa dei modelli linguistici di traduzione automatica, e Bertana IT invece si occupa della sicurezza informatica, dell'infrastruttura del prototipo. La nostra cooperazione quindi è a livello quotidiano, come ho anticipato, e come unità assieme al consorzio ci occupiamo di collaborare su 4 aree principali. Prima di tutto, come ho già anticipato, essendo il progetto parte della Direzione Generale per la traduzione, l'ambito linguistico è quello principale. Supervisioniamo lo sviluppo e la valutazione di tutti i modelli linguistici, ma allo stesso tempo, e qui entrano in gioco tutti i diversi profili dei colleghi che lavorano in questa unità, ci occupiamo ovviamente delle funzionalità della piattaforma, quindi migliorare la user experience, migliorare l'interfaccia e l'accessibilità, l'infrastruttura, quindi l'architettura informatica del software, e l'integrazione nel contesto informatico del Parlamento europeo, cioè stiamo studiando come integrare il prototipo nel nostro contesto informatico una volta che la fase 3 del progetto sarà finita. Vorrei adesso, dato l'argomento di questa conferenza odierna, semplicemente menzionare un paio di sfide che ci troviamo ad affrontare per quanto riguarda la traduzione automatica. Come avete visto, per poter permettere a qualsiasi utente europeo di accedere all'output nella propria lingua, abbiamo implementato una funzione di traduzione automatica in tempo reale. Questo porta a determinate sfide, prima tra tutti è il fatto che ci occupiamo di discorsi orali, quindi discorsi spontanei all'interno di dibattiti molto rapidi, in cui spesso capitano riformulazioni o esitazioni da parte degli oratori. Non siamo quindi di fronte a una struttura testuale tipica di testi scritti. Per questo motivo il nostro software è stato sviluppato in modo autonomo rispetto ad altri software di traduzione automatica che magari potete ovviamente tutti conoscere, come ad esempio i Translate dei nostri colleghi della Commissione europea. Il fatto proprio di avere a che fare con discorsi spontanei, preparati ma comunque molto rapidi, perché gli eurodeputati hanno di solito 1 minuto e mezzo per poter parlare durante le sessioni plenarie, ci porta anche a dover fare i conti con determinati tipi di errori. Ci sono casi in cui la trascrizione automatica potrebbe avere errori dovuti a riformulazioni o pronunce magari non del tutto corrette o segmentazione, e questi errori dalla trascrizione automatica originale vengono poi a volte amplificati nella traduzione automatica, quindi possono risultare in alcuni casi in errori ancora più considerevoli per l'utente finale. Queste sono tutte sfide che stiamo affrontando in collaborazione con l'azienda, con Citato 85, che ci aiuta ogni giorno, e speriamo di poter migliorare ogni giorno di più da qui alla fine del progetto l'output di entrambe, la trascrizione e traduzione automatica. Come possiamo occuparci di migliorare o comunque garantire un certo livello di qualità linguistica per tutte le 24 lingue del Parlamento europeo? Anch'essa è una sfida considerevole, ma nella Direzione Generale per la Traduzione abbiamo il grande privilegio di avere molti esperti linguistici nativi in tutte le 24 lingue, e per questo motivo come unità abbiamo messo in atto una procedura di valutazione molto accurata in diversi modi. Prima di tutto abbiamo delle regole che dobbiamo seguire stabilite dalla gara d'appalto che Citato 85 ha vinto. Queste regole comprendono anche l'utilizzo di metriche automatiche, quindi la trascrizione automatica tramite un calcolo di word error rate viene confrontata con una trascrizione creata dai nostri esperti della Digitrad per controllare il livello, la percentuale di errore. Abbiamo anche metriche che vogliono controllare la velocità, il tempo che passa, diciamo, tra l'audio originale dell'oratore e il momento in cui la trascrizione e la traduzione automatica vengono mostrate sullo schermo. Questo per garantire una buona esperienza per l'utente, quindi poter avere accesso rapidamente a un output chiaro e corretto, ma la valutazione umana è quella che diciamo è più caratteristica del nostro progetto, in quanto, come dicevo, abbiamo il grande privilegio di lavorare con molti professionisti del linguaggio della Digitrad. È proprio grazie a loro che regolarmente controlliamo tutti i modelli linguistici e ci occupiamo di controllare la qualità della trascrizione e della traduzione automatica in tutte le lingue che vengono sviluppate nel nostro prototipo. Sono quindi giunta alla conclusione di questa presentazione. Spero di avervi fornito un quadro chiaro del progetto su cui stiamo lavorando, ma per qualsiasi tipo di approfondimento, domande o curiosità lascio la parola al mio capo unità. Grazie mille per l'attenzione.
Thank you very much. Right on time. Probably practiced this before. There is already one question in the chat, so I'm just going to read that for everyone's benefit. So the question is, in a potential future application of this method, what would be the pros versus the recourse to the model interpreter plus re-speaker to produce subtitles for the deaf and hard of hearing?
Okay, if I can take that one, we are aware that the best possible solution would be to provide sign interpretation for the deaf and the hard of hearing. But for a number of reasons, including logistics and budgetary reasons, this is at least at this stage, this is not really an option. And the same applies to interpreter plus re-speaking. So this is the most sort of viable option that we've been able to come up with, and also bearing in mind that although, as I said at the beginning, our primary audience would be the deaf and the hard of hearing people, there are other potential users that could benefit from this technology. You know, you have a lot of examples on social media and things like that, where a lot of content is consumed with auto-generated subtitles or whatever texts, because people follow the audio and video content in silent mode. So there are some objective sort of logistical and budgetary reasons that we opted for this approach.
Thank you. There's another question. If you considered or are planning to include the hard of hearing community in testing the output?
Yes, directly and indirectly, because we also plan to work with some experts on audiovisual accessibility. So both options are on our table. As Martina was explaining, we already have a few options, few basic options, accessibility options that we already included in the prototype. It's also good to know that our primary focus has so far been and will continue to be linguistic quality. And we are now entering into this sort of additional stages or options where we look at accessibility options, and hence we didn't sort of do it from the very start, but as I said, it's our intention to do so. Yeah.
Okay, there is a further comment and a question regarding maybe another possibility, but I think you already touched on that. And this suggests that intralingual re-speaking could be provided by current interpreters, provided some retraining followed by MT.
Well, it's way beyond my pay grade to decide on that. It's a logical option. It would be very nice to that, but it's not for me to decide on the scope of on the job description of certain linguistic or linguists in the parliament.
Okay, can you, if I, because it's quite an interesting comment, and in some contexts, you know, there is this idea of prioritizing certain content. So do you envisage a scenario where maybe such a model could be used for maybe sessions that are deemed you know, to be more important than others, or there isn't you know, there isn't such a classification in the work that you're doing?
No, I mean, you wouldn't prioritize meetings in the parliament as we do, and I come from the interpretation service where I worked before, so there is nothing like a more important or less important meeting. You just provided linguistic services where you can, and this particular linguistic service that we're trying to provide here is to fill in a certain gap, as I said, as we said, because we have interpretation that is provided in real time for the meetings that we can provide interpretation for. We have translation services to provide background documentation and so on and so forth. And this particular project, as we said, is aimed at the deaf and the hard of hearing because they had no access in real time whatsoever to our debates. So it's an additional linguistic service to fill in the gap, and there is no meeting priority. In the future, we can actually, currently the scope is limited to plenary sessions, but it's quite imaginable and possible to extend it to other types of meetings. But no priority will be given, I don't think so.
And you your colleague very nicely described the types of quality measurements that you have put in place. And I have a question. So before giving the green light to this system being applied live, is there a certain quality threshold that you're going to apply to the output? And if so, is that threshold similar for all the languages that you are implementing?
No, the threshold is not similar for all the languages. We have a very general sort of holistic grading scale. Basically, there are 3 levels: good, acceptable, and unacceptable. This is all specified in our call for tender, which everybody can access by Googling LSTT, European Parliament, and e-tender, and you will find the full document there. And it's a grading scale, and it depends basically on the number of data we have for each language. So let's say for English, we have a lot of data, so we expect the best quality from the start. But for was it Polish? No, Polish maybe not, but let's say Romanian, for example. In the first year, we only expected the middle quality because we knew we didn't have that much training data, and we would consider this level as acceptable for us, with the proviso that the models have to be continuously improved. So in the first year it's the middle quality, but in the second year it will go up to the top quality, and so on and so forth. And in year 3, for the smallest languages or the less widely spoken languages, to use the correct term, we really have significantly less data, so we expect the sort of middle quality, and then once the tool is put into operation, is put into production, we will continue improving the models because we will acquire more and more data. But we have to be realistic. So we're sort of operating on this sort of good enough principle, basically.
Okay, there are 2, I'm aware of the time, but I think the questions are really interesting, and also everybody's very interested in the answers that you're providing. So there's another question about, so the question is, why use word error rate as a measure of accuracy? With impromptu speech, there is a need for human editing, because if you transcribe everything and translate everything, sometimes the output is difficult to understand because it might include repetitions, redundant material, etc. Is there no space for human editing in the workflow at all?
No space for human editing in the workflow because it's in real time. So you cannot afford to have human editors intervene in the process. And word error rate is just one of the metrics that we're using. It's an automatic metric. We are quite generous in applying this metric, but we put our main focus on human evaluation. So we are very much aware of all these things that you've just mentioned. And our sort of the word error rate is to basically, I wouldn't like to say to tick the box because it's not about that, but okay, it's a kind of a safety measure, but we mostly rely on human evaluation. And as I said, where is quite generous, and we know, and we've already, and I think Martina mentioned this in her presentation, that it's really very interesting to see the sort of link between automatic speech recognition and machine translation, and the fact that we're applying machine translation to basically translate live speech and not written texts. I know that one of our colleagues is following the presentation, so if we have some time, maybe she could elaborate on the metrics and on the evaluation, but or we can take it offline later on.
Thank you. There's an extra comment regarding a project and intra speaking, where, you know, saying, so this particular colleague is saying that actually alternative workflows could leave space for human editing. I'm sure you can react to that in the chat, as well as if you could take a few minutes to also answer the question about machine translation evaluation and the metrics that you are using there, given that we don't really have a lot of time left now. Thank you very much for your intervention. Really, thank you to Martina and to Marcin, and to your answers. And we will now go to the Commission, where our colleague is going to also tell us about adapting and developing a speech recognition system, but this time at the Commission. And I'm sure a lot of the questions that we had in this session will probably also apply to your intervention. Without further ado, the floor is yours. Thank you.
Thank you, and good afternoon, everyone. My name is Vilmantas Liubinas. I will share my presentation in a moment. Okay. And I will hide the elements of the screen. Hide floating meeting controls. Okay, now it should be okay. So, I work as a computational linguist in the e-translation team at Directorate-General for Translation in the European Commission. And my team is mainly involved in machine translation. As you may know, it's e-translation, very popular service among public institutions, for example, in the national states, small, medium-sized enterprises, and so on. But today I'm going to speak about speech recognition systems at the European Commission, not about machine translation. Yep, I'm trying to change the slide. Here it is. Okay, so today's plan is, firstly, I'll present to you the main overview of speech-to-text activities at the European Commission. Then I'll go to specific services. Firstly, the upload-based speech-to-text web service, and then live speech-to-text service. And then a couple of words of motivation behind the current technological choice that we've made. And I'll give away the technological choice that we made just recently. It's fair sex Facebook artificial intelligence research lab technology Wave2Vec 2 and its models. We're trying to fine-tune them. So this is a small plan for this afternoon. And let's first look at general activity, at the general overview of what we're doing at the European Commission. So we're not only involved in live speech recognition, as we heard before from the European Parliament, but we are also and firstly involved in the recognition service for uploaded files. It's a public speech recognition service. It's organized by several Directorates-General of the European Commission. I won't go into detail about who is doing what. This service is funded from the Digital Europe program for 2021-2027. The next service, similarly to the European Parliament service, is live speech recognition, and it's organized mainly by the Director-General for Interpretation, and it's an internal service of the European Commission. The public web service is freely available to all EU national public administrations, small and medium-sized enterprises, non-governmental organizations, and of course, the European institutions themselves. The main principle we're following in our work is the one that we are focused on practical implementation, not fundamental research. And we will implement all 24 languages in our system eventually. That's also very important when we choose the system, when we make a selection of the potential system that we integrate. Our activities mainly include integration and customization of off-the-shelf speech-to-text systems. The next thing is just fine-tuning models pre-trained by other companies. Then we also collect public and in-house audio data for future training of models, and we are going to train, actually, it's the future activity. We're going to train in-house models based on open source frameworks of our choice. Another principle we follow is that we're not locked in any technological choices. We're oriented towards free solutions, open source solutions. And generally speaking, we're moving from easily customizable products such as Microsoft Azure Cognitive Services towards more complex models, more complex model training. And we're going to train models in-house eventually, using such toolkits as SpeechBrain potentially. So let's move on to a specific service that we provide, this public service, upload-based speech-to-text web service. Let's discuss how it works. This is the front end of the language tools page that we have for e-translation users. As you can see, there are several language tools available, and one of them is speech-to-text. So when the e-translation user clicks on this box, he sees the following interface. It's really self-explanatory. You just upload audio and video files to the system. You choose the language. Currently, we support only 4 languages for the moment. It's German, English, French, and Spanish. Then the user chooses his preferred version of the fine-tuned model that we provide, that we prepared in advance. And then the next selection is output format. So in terms of input formats, those are all typical formats, audio, video formats. And the output formats are basically docx as a transcript of the speech, and also subtitling files, first of all, SRT format, and VTT is also available. So in an hour or half an hour or 2 hours, depending on the file size, the e-translation user gets the reply, the final result of a transcription, and the user can download his transcription to his computer. As simple as that. And now I'll reveal the technology behind this service. The technology that is used right now, as I said, we are not locked in the technology. It can change, but at the moment we use Microsoft Azure Speech-to-Text REST API version 3. And popularly speaking, it's called batch transcription. Microsoft offers lots of speech-to-text services, so it's sometimes difficult to understand what is what. And in fact, we're not using Speech Studio, we're not using Speech SDK, Speech Command Line Interface. Those things were not used by our service, but it's batch transcription. So how does batch transcription works? Again, it's an elementary diagram. The user on the left side uploads audio, video files to the browser, and the files come to the e-translation service that forwards the files to Microsoft Azure Web Service, which is asynchronous, meaning that it will process the file using our customized models that we prepared in advance. Then Microsoft Azure Cloud Service sends back the transcript to the e-translation service in JSON format, in the structured data format. The e-translation service processes this data file and creates subtitling files and docx or docx files, and then makes available the files to the user. Speaking about customization, it's really an important part of Microsoft Azure service. Microsoft offers a selection of trained baseline models in all EU languages, but an important thing is that you can customize them as a user of their system. So we use this possibility, of course, because we needed to adapt models to the European context. And there is several possibilities how you customize models, but in fact, we did it only using the last option out of the 3 that you see on the slide. We supplemented the baseline model with our reference text. It is possible theoretically to upload up to 200 megabytes of various files for linguistic models of Microsoft. But in reality, we used approximately 20 megabytes of supplementary files. And here are several examples of what kind of files we sent to the service of Microsoft to fine-tune the baseline models. We included some international family names. We included some EU-specific acronyms, structural divisions, programs of the European Union. An important part and interesting part was that we also uploaded hundreds of transcripts of speeches by EU officials and also press releases, questions and answers on EU-related topics. So those were our customization points. As a good example, use case of customization, I could mention the conference on the future of Europe that took place last year, and we fine-tuned to customized models for this conference, for a multitude of plenary sessions and for panel discussions of this conference. So English and Spanish language customized models were used and successfully for this conference. So I'll say a few words about whether the customization works at all. You can see on the left-hand side that the baseline model made initially several mistakes transcribing the family names of the European commissioners. And on the right-hand side, you can see the custom model which corrected to some extent the initial mistakes. For example, the family name Oliver Varheli was erroneously treated as Oliver Warhead, and Jutta Urpilainen was also misunderstood by the baseline model. The custom model corrected some mistakes, but left the output in lowercase, as you can see. Several challenges that we faced included, for example, the fact that Microsoft provides no capitalization or punctuation for word-by-word mode when in its subtitling output. So we needed to resort to some other measures how to solve the problem. It's just a tiny problem during the implementation of the system. Another challenge was that large file sizes can sometimes cause the problem. Just imagine that video sizes can even exceed 1 gigabyte. So it's really difficult to ensure the stability of the system when several users perhaps upload files of 1 gigabyte in size. So in the end, we suggested users to split files into chunks, or perhaps extract audio channels from video files. The suggested methods were simply command line tool, ffmpeg, or we even designed a small, simple application which is called Sound Splitter. I've put it on GitHub. You can download it if you want, and it's available also as a Python code for you to tweak it. It's just a drag and drop tool that splits files into chunks or into audio channels. The second service, the internal one, is similar to the European Parliament's service, but it's internal in the European Commission. It's provided for internal use only, as I say here on this slide. It's a synchronous Microsoft Azure Web Service. Again, we use Microsoft's services. The service is actually still in preview. Also, Microsoft declares it so. Currently, it's implemented in one conference room in Berlaymont building in Brussels as a pilot project for spokesperson's service. They are happy with the service. And an interesting aspect that I would like to stress is that the language is recognized on the fly. And if the language changes, the transcription is adapted accordingly. There is also a possibility of translation to all EU languages. And now I would like to show you the example of how it works. Please look 10 words back when you see the transcription.
Vient de présenter ce
I'm afraid we're not seeing or hearing anything.
Okay, never mind then. I'll probably continue with the presentation. Okay, the interesting thing about this video was just to show you that the system nicely catches the change of language. At first, the person speaks in French, and then he changes into English, and the change of language is caught nicely by the system. Now I'll say a few words about our technological choice. As I gave away already, it's FairSex Wave2Vec 2 model. We are currently experimenting on the on these models, we're trying to fine-tune them and use them, and we are going to link them to the web service that we have for uploadable files. So let's take a look at our motivations. Firstly, the challenge of any speech-to-text system is, of course, that the input data is of a large size, and you can see 3 images here of the same sound file. It's actually the sound file of me saying the word "oh," and you can see it in 3 levels of magnification. The bottom file is just the very magnified view of the sound. So that's how sound looks like. It's just a bunch of numbers, actually amplitudes of a sound, and these amplitudes somehow have to be converted by the speech-to-text system into letters, words. This is another representation of the same small sound file. It's a half a second small file. And in fact, we expect that the speech-to-text system transcribes this entire bunch of numbers into 2 letters, O and H. So we need the output of 2 letters from this entire bunch of numbers. So you can see the extent of the problem of any speech-to-text system. So 2 main approaches exist, if I can say so generally, how systems approach the problem. So there is a classical method, and there is a classical tool, Caldi, that does the following. In fact, the sound signal is divided into small intervals, and each interval receives according to the data in each interval of sound, 40 features per interval are calculated using some mathematical formulas. And then those intervals, those features actually are linked, aligned to the phonemes. And out of those phonemes, we can then derive the words, the human readable words. And for such a system to be trained, we actually need a lot of data which has to be labeled. It means that the audio data has to be supplied plus the labeled, plus the text transcription. And not only that, not only 1,000 hours of label data has to be supplied, but also the lexicon. And here you can see the lexicons example. The lexicon means that there must be a pronunciation provided for each and every word used in the transcription. So it's a very, very lengthy and costly process if you want to use such classical systems. Another approach that we decided to use is actually FairSec Wave2Vec2 technology. FairSec, Facebook's AI lab, uses innovative technology Wave2Vec2 that learns a vector representation of a short interval of sound from, the keyword here is unlabeled data. So here we don't need that much labeled data. We can use unlabeled data. And from this unlabeled data, they are able, using the deep neural networks, they are able to derive certain vector representations per each interval of sound. And this, each interval is also contextualized depending on the neighboring intervals of sound. So in the end, we, after the training, based on enormous amount of data, of unlabeled data, we get certain vectors, we can get certain vectors for small intervals of sound, and then use those vectors further on in the downstream tasks to train on, to fine-tune using labeled data already. So there is a second process which is attached to this first stage. So Facebook, well, not Facebook, it's Meta nowadays. They issued 3 batches of such models. The first one appeared 2 years ago, and it was monolingual. So they just presented the technology, and they said that the monolingual models can be trained, pre-trained, based on unlabeled data, and then using, let's say, 10 minutes of labeled data, you can already get some good results. And as an example, at the very bottom, you see the third line, and there is a, I indicated that they achieved 4% word error rate with the training on, with the pre-training on 53,000 hours of unlabeled data and 100 hours of labeled data for English language. It's a pretty good result, actually. The next 2 batches of models were already multilingual models, and it was another interesting approach that they said, Facebook guy said that models can learn the common human characteristics of the speech, and you can actually combine many audio records in many languages and learn certain characteristics of sound, and later on you can fine-tune this powerful model using some small amount of labeled audio data. So those are multilingual models. Also, for fine-tuning, you can use several languages at once, they said, instead of one language at a time. And if you are very lazy as a user, you can also use already many fine-tuned models that exist on the market, just out of the box. Just to make it a little bit clearer, you can see that at the bottom you have the pre-training part, and at the top you see fine-tuning part. That's how it works. So we would use, let's say, a FairSex pre-trained model. We would supplement it with some labeled data for fine-tuning, and in the end we would get a very nice functional model that we could use for our own services, using only a small amount of labeled data. That's the catch here. And the final slide, we are going to use SpeechBrain Toolkit, which is a very nice open source project launched last year. It's an all-in-one toolkit that allows leveraging wave-to-vec technology. It's based on PyTorch library. It includes many interesting use cases, not only speech recognition, but also speech diarization, language identification, and so on. So we are also planning to use this toolkit for our modeling. So thank you. And perhaps you have any questions?
Thank you very much. Thank you. It was very interesting to see your approach as well, and to see how you evolved in your use and in your customization. There are no questions at the moment, so maybe while my colleagues are writing, I'm going to ask a question. Roughly, how long does it take you and your team to customize a model to then make it available? And when you do so in customization, again, what kind of metrics are you using to evaluate the models that you produce?
Realistically, to customize Microsoft models, you mean? We've used, I would say, at least a week for the collection of reference documents, because we need to collect a very nice and clean selection of documents. For example, speeches. You have to crawl lots of speeches, lots of just finding documents. It takes a lot of time. So I would say count 2 weeks maybe for all those things. And speaking about the metrics, it's very important to, again, as my colleague from the European Parliament said, it's important to test, to have them human tested, first of all, especially using the things that you want the model to transcribe correctly. So you have a certain list of words, phrases, and then you test the model, how it reacts to all those new strange words, your jargon, and the word rate, of course, is the main parameter, which is actually nicely indicated when you customize models. It's a very user-friendly system that the Microsoft has, and you can, for example, see the difference between in their system, that you can see the difference between the baseline model and the custom model side by side. So they made it nicely, and it's pretty easy to see the difference. Although you can actually ruin the model if you over customize it. You just have to be really aware that you can ruin the baseline model.
Okay. Thank you very much. Thank you again for your intervention. I don't see any further questions in the chat. Thank you. And I think now we will take a break. I'm aware that we went 10 minutes over, so Annalisa will tell us what if we have 5 minutes or if we have more. Thank you again.